We'll jump in. Giselle, you're making an animation? That sounds awesome. I would love to hear that, or to see it. So when it's done, let us know. We'll show it. They humped them on Halloween. That's so sad. Who humped them? I don't know. That's sad. All right. So we're gonna jump in. Gally, if you could post that link one more time, please. So for today, we are going to jump into like a normal class, right? For the last few weeks, we haven't had class. And then before that, we were doing PT. Before that, we were doing like wrap up stuff and quiz stuff. So it's been a minute since we have like had like a normal class day. So we're going to have a normal class day today, which is awesome. I have some announcements and then we'll do notes and assignments. So we will make it happen. Really excited. All right. So thank you so much to everyone who said something on the teacher report card. Really, really appreciate your feedback and thoughtful thoughts, because I read every single one and they were super duper thoughtful. So appreciate you, whether you put your name on it or not. Awesome. There were like some themes, which I'm going to pull out and just like tell you about, and then tell you like how we're going to move forward. So for like good things, people were like, the energy is good, the vibes are good, extended office hours, that was good, background music is good, I'm here for that. People really like knowing what day it is, so I'm glad to know that that was like the #1 most commented thing, was like, I love knowing what day it is. And I was like, oh, that's cool. And then people said like, it's simple, like it makes sense and it's clear, so that's good. So all those things were good. And then then there were like a few like sticky points, especially for our class. Some people think that class is going too fast, and some people think that class is going too slow, which is very normal. I think like everybody has like a different style that they want. So one of the ways I'm going to try to solve for that is I'm going to try to make the videos available so that if you think class is going too slow or too fast, you can jump onto the video and either watch the video multiple times. If you think it's like going too fast and you want to watch it again, or if it's going too slow, then you can like watch it at 1.5 speed or whatever. So the video is hopefully helpful. If you have any other ideas for how I can make it like go the right speed, that'd be great. And then there were a couple questions or like a couple comments about it being hard to ask questions in a big group, and that's kind of scary. I get it. It is kind of scary. There's 35 people on the call, but it's also like asking questions in class. So I would really encourage you to not feel scared to ask questions, and especially because you have a private chat box. Like no one even needs to know that you asked that question. So I would really encourage you to do that. I think it will also help to build your confidence for college, when like it could be even scarier to like ask your professor a question. So I would definitely encourage you to keep asking those questions. And then there were a few suggestions, which you can see in the yellow box here. Maybe adding do now so we can remember what we've done in the past. Maybe adding ACT problems, like optional ones for people who are trying to like get their ACT score up. And then like more examples, details, instructions, and explanation. I think those things like all kind of go together. I'm going to make sure to provide more videos for those people who are interested, but I am like kind of stuck with the 45 minutes, as I think you guys will see today. Just so like, I'm going to own that it's going to take most of our time today to just do the notes. And so as our like class content gets more complicated, our notes time will be longer. I'm going to try to balance that, but just want to like own that for you guys. And then maybe a tracker for like the work, because I think just a couple of us got like a little behind or confused. That's totally fine too. I get it. This last one, the more focus on ACC, was just like for my other class, so no big deal. I think those were our major comments and concerns. I'm excited to continue thinking about them and how we can make like class better. You also don't have to wait for next quarter to tell me things that I'm doing wrong. I had a couple email conversations with a few of you guys, really appreciated that in terms of just like getting your feedback. And I love feedback. So if you want to give me feedback anytime, I won't think that you're being rude. Just tell me what you need, and I'll try to make it happen for you. Okay. Any questions about all of these things? I know I've already been talking for like 10 straight minutes. No. Cool. Okay. If you do have any comments or questions, feel free to put them in the chat or send me an email. So announcements are done. We are going to jump into our notes section. So there is a video option for the notes today if you are interested in doing the notes. It is on Canvas on today's page. It is on the assignment for today. And it is also, if you like, comment, subscribe on my YouTube channel, you can also find it on my YouTube channel. But that's probably like the most annoying way to get there. You can also find it on Canvas and today's assignment. Okay. Any questions about the notes for today? Okay. Very cool update from Zoom. One of the cool updates from Zoom is that you can now self-select into breakout rooms. So I'm gonna, let's see. I think no one is still in them. Great. I'm gonna close these rooms really fast. And then I'm gonna open them again. So now when you click the little breakout room button, as long as you've done the update, which hopefully everyone's will have auto updated by now, but as long as you've done the update, you can actually like choose a breakout room you want to go into. So it will still like assign you to your regular breakout rooms, like the ones that you've been using for Q1. But now if you need to switch and go talk to someone else, you actually can do that, which is very cool. So I'm gonna recreate these. Recover to pre-assigned. Cool. I think everyone's going to be in them. You can either go to your room if you want to do the video, right? And you just need like a quiet space. There's also independent workspaces available, so you'll see them, or you can just choose a breakout room at your choice. So the rooms are open. You can go to them if you wish to. If you wish to switch, you can also switch. I may have sent everyone. Interesting. Miriam and Kayla, did it auto send you? Or did you just like not select it? I don't know what happened exactly. You selected for later. Cool. Okay. People who are here, are you here? You did not select. Cool. Is everyone here that wants to be here for the notes for today? Can you either give me like a thumbs up, a blue thumbs up, another thumbs up, a yes in the chat? Cool. Lots of thumbs up happening. Awesome. Okay. We're going to jump in. Let me pull up these notes here. All right. Let me screen share. All right. All right. Can you guys see my screen now? Does it say Notes 11? Yeah. Okay, cool. So we're going to jump into Notes 11. I want to own that like these are probably going to take a pretty long time because there's just like a lot to cover today in order for us to like be ready for what we need to do. So there will be a lot of notes today, but there should be very few notes on Thursday. But we're going to work on the same concept all week. Okay, so you should have lots of work time on Thursday. So it's a balance. All right. So today we are jumping into factoring. Factoring is like the thing where you have like parentheses like this, right? Or like you might have like a number on the outside. There's lots of different types of factoring. We're going to go through all of the different types of factoring today. It should be generally a review, but might be a review from like all the way back in 9th grade. So I want to make sure that we are like maybe even 8th grade for some of us. So I want to make sure that we're like refreshing our brain. So the number one rule of factoring is that before anything is done to the polynomial, the terms must be ordered from greatest to least degree. So what I mean is like if it says x squared, x to the third, and x to the fifth, we need that x to the fifth to be first, and then x to the third, and then x squared, and then x, and then a number if we have it, right? We need them to be in decreasing order. Okay. And then beyond that, there's a bunch of things that we can check for to break the polynomial down into parts. Because ultimately, we want to take something that has like a bunch of parts like this, and we want to turn it into at least 2 parentheses, if not like 3 or 4 even parentheses. Okay, so that is the ultimate goal. So the first thing, I would call that even like step 0, is like put in order, decreasing order. In decreasing order. So we're going to put it in decreasing order. That's step 0. Then step 1 is always going to be to look for a GCF, a greatest common factor. And that might include taking out a negative if there's a negative at the beginning. So we'll do that. Okay. So the second step, the first like strategy, is to look for the difference of squares, right? The difference of squares is like, if I have like x squared minus 49, right? You might remember that this can be turned into x plus 7, x minus 7, like that. Are we remembering this at all? Callie's shaking her head. Thought I used like maybe. Yeah. Okay. Okay, so remember that if this is a square and this is a square, then we can break it into its parts. So for example, here, I'm going to make sure that it's in decreasing order. It is. We have x to the third and x, so that's good. I'm going to look for a GCF, something I can take out of both of them. There is a GCF here. You can take out an x from both, and then 2 and 32 have 2 in common. So I can take out 2x from both. That's going to leave me with x squared minus 16, like that. Okay. So that's the first step. That's GCF, right? So this is GCF. And then the second step would be actually the difference of squares if we have it. So I see x squared is a square, and I know 16 is a square, 4 times 4. So I'm going to split this into x plus 4, x minus 4, and bring the 2x down. That would be my final answer. This is the factored form of this. All right, so those two things are equivalent. They're the same. They're just written a different way. We've broken them into their pieces. Okay. I'm going to give us a moment to try this next one on our own. Try this next one on our own. Don't forget, we first need to rearrange because the x to the third is at the end. So I'm going to start by rearranging. Plus 12x. So that was step 0. Now you need to do step 1, which is the GCF. So go ahead and start. I'll be quiet for a moment. All right. What GCF can we take out of this equation? (3x), yes, for sure. And since it's negative at the beginning, I'm also going to take out the negative. So I'm going to take out negative 3x like this. And what would be left over is x squared minus 4. Okay? X squared minus 4. The reason it's minus because the negative and the negative make a positive 12. Right? So since I have x squared minus 4, I have the difference of squares. Right? So I'm going to have 1 plus 1 minus. What would it be? X plus what? Two, yeah, x plus 2, x minus 2, like that. I'm still going to bring down the 3x. So that was step 2. Okay, so that is my final answer. I forgot to mention as well, if you're getting stuck on any one of these and you want just like a refresher, I attached a refresher video in the notes section, so you can check that out if you need to. Additionally, on the notes page, I have a third example. So if you're trying it later, people are asking for more examples. So if you're trying it later, there is another example here. And then if you scroll all the way down to at the bottom of the notes, it actually has like the example like worked out, so you can check your answers. So we're not going to do it together, but you will have the option. You can do it if you want. All right. So it might be the difference of squared. How did I get the -4 from the 12x? Great question. So when I had here, when I took out the -3x from both of these, I did 12 divided by -3, and that makes -4. And then the x's would cancel like that. So factoring that out is how I got the -4. Cool. Thank you for that question. Good job asking a question. Thank you for using the private chat. That lets me not tell everyone who you are. Great use of the private chat, just like we were saying. Okay, cool. Then Miss Joelle told me that you have already done the sum and difference of cubes. So I'm going to remind you what it is. But again, if you're like, what the heck is that? Or like, I was absent that day or whatever, then you have the refresher video there. So the sum and difference of cubes, I call it the ombre formula because it goes from like one color to a different color, like ombre hair, you know, when you have like, your like roots are dark and then you have blonde tips or whatever. It's called ombre. Anyway, you have a squared, b squared. So the reason I call this ombre is because you're going from like a to b. You're starting with a lot of a, then you have some a, some b, and then you have a lot of b. So that's just like how I remember it. The ombre formula. And then how you remember if it's like plus or minus is it's SOAP. So it's same, opposite, and then always positive. I wrote this probably the wrong way. Try this. SOAP. So same as the problem, opposite of the problem, and always positive. Always positive. So in this situation, we have x to the third is a cube. And then we have minus, what would 27, what number cubed is 27? Three, yeah, three. 3 cubed. Awesome, great job, chat. 3 cubed is 27. So this is basically our A and our B. So x is our A and 3 is our B. So I would have x, 3. Then I would have x squared. And then I have A times B, so x times 3. So that'd be 3x. And then I have B squared, which would be 3 squared. So 3 squared is 9, like that. The same starts with like the same as the problem. So it starts with a minus because in the problem we have subtraction. If it was addition, we'd start with addition. And then the second sign is always the opposite. So since we have subtraction here, it's going to be addition. And then the last sign is always positive. So we put positive there. This is the final factored form of this. So if we were to multiply those things back together, we would get x to the third minus 27. Do we remember this? Sort of. Yeah, no. Some people yes, some people no. Thumbs up, thumbs down. Vaguely. Okay, great. That's totally fine. No, not really. Okay. Let's do another one then. I'll do this one with you rather than like releasing you. So first step, putting them in order. So I have x to the 4th, so step 0. X to the 4th and then x. So we're good. Second step, step 1, is GCF. Do we have anything that we can GCF out of here? We could take some stuff out, right? So what, yeah, 2x. We can take 2x out, for sure, for sure. So we can factor out 2x. We can only take out x to the power of 1 because there's only one x on 16x. We can only take out 2 because that's the biggest thing we can take out of both. So I would have 2x on the outside. And then left over, I'd have x to the 4th, take away 1, I'd have x to the 3rd. X to the 3rd plus 8 because the x's will cancel. All right. So is 8 a cube number? Is 8 a cube? Yeah, it is. Yeah, it is actually. What number is it cubed? It's something cubed. What is it? 2, 2, 2. Yeah. So 2 to the 3rd, and this is x to the 3rd, right? So now we have our a and we have our b. So my ombre formula, remember, is a b times a squared. I don't know if it's plus or minus. A b b squared. Since this is a plus, it's going to be a plus to start, same, and then opposite, minus, and then always positive at the end, plus. And in our situation, we're still going to have the 2x out here. Okay, so I'm bringing down the 2x. I'm plugging in the a, which in this situation is x. So I'm going to have x plus the b, which in this situation is 2. I'm going to have 2. So then x squared minus 2 times x, so 2x, plus, and then b is 2, so 2 times 2, or 2 squared, which would be 4. Since this is a somewhat new topic, what questions? I'm sure there's some questions out there. What questions do we have? No questions? Okay. 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 All right. So again, I have another question there, but that's just for you at some point. Oh, yes, questions. Okay. Number 1. So if we start negative, we add it first. Okay, so if the original problem has a negative in it, then negative goes here. Right. So then if we have a positive, then the positive goes here, the first part. Yes. Okay. So if we have, so like if this is my formula and it was like x squared plus 343, right? Then I would put positive, negative, always positive. If it was minus, then I would put negative, positive, always positive. So those are the questions there. Yes. Thank you, Ollie, for letting me know. I think, yes, that's the trend. That's the trend. The middle is always the opposite, yeah. So that's like how so this SOAP is like the acronym or whatever. So like the S stands for same. So the first one's always the same. And the middle one is always the opposite of that one. And then the last one is always positive. That's what the A and the P stand for. The last one's always positive. Should we do one more of these together? No, Galilee's the only one saying yes or no. No, yes. Okay. I think that there are a few of us who would love it, so we're gonna jump in. If you're feeling comfy, you can try to do this one on your own. But I'm gonna do this one with us. So first thing, check that they're in order, which they are. Second thing, GCF. So -3, -3, x and x. So I'm gonna take out -3x. That's gonna leave me with x to the 3rd minus, I don't know what that is. 192 divided by 3, 64. So 64 and the x's will cancel like that, right? So 64 is 4 to the third. 4 times 4 times 4. So I know that that's a cube. So I'm going to bring down the negative 3x. I'm going to have, oh, good question. Thank you, Kayla. It is not minus. It is plus. It is plus because the minus and the minus should make a plus. Thank you so much for catching us, because that should be a plus sign. Negative divided by negative is a positive. Yeah. Thank you, Kayla. Cool. So I'm going to have my A, B. So in this situation, since it is a plus sign, I'm going to start with a plus. The second one is the opposite, so it'll be minus. And the last one is positive. Question from the chat says, what if you can't cube the last number? If you can't cube the last number, then you can't do this for it. So you'd have to use either a different strategy or decide that you can't do it. Yeah, so you have to be able to cube them. So this only works for the cube numbers like 1, 8, 27, 64, 125. There are only a few numbers that work. Yeah. Okay, so since this is a plus sign, we're going to do positive, negative, and the last one's always positive. So we would have x plus 4, x squared. We have x times 4 is 4x, and it's minus. And then plus 4 times 4, 4 squared, 16. So this is our final answer for difference of cubes. Amazing questions. Good questions. You can also, if you feel confident, come off mute. But I get it. I have some background noise, so get it for sure. Cool. Okay. So both of these strategies are useful if there are two terms, right? Notice like in the first one, there was like 2 terms. In the second one, there's 2 terms. In the first one, you have 2 terms that are squares. And in the second one, you have 2 terms that are cubes. Okay, so both these are useful for 2 terms. And my pencil died. So both of these are useful for 2 terms. We're now going to look at one that has 3 terms. This should feel more relaxed or like more familiar to you because you've done a lot of factoring in the past. So we're actually going to start with this one. So if you're writing it down, we're going to start with the one that's circled in pink right now. So start with this one. Cool. Okay, so for this one, do you guys see how this is set up? Like it pretty much looks like this, 4x minus 5. Yes, it has 4 instead of squared, and it has squared instead of nothing. But this is just like the multiple version of that. So if it has x to the 4th, right? Then we need this to be x to the square. It could also, like you could also do it if it was like 6 and 3. You just need it to be doubled. Okay. So we're going to use, when we learned factoring, did we learn the x factor? Did we learn this thing? Or did we learn the thing like you have to multiply to get this number, add to get this number? How did you guys learn it? The second one? Gallery's gonna do that? Yeah? Maybe we learned both. Usually did FOIL. Oh yeah, FOIL to go the other, like just guess and check. You can also do guess and check. So I'm gonna show you maybe 2 ways to do it. I think the easiest way, the way that I learned when I was in high school, is that whatever this number is, you have to add, you need 2 numbers that add to get this middle term and multiply to get the last term. So we have taught it in the past with like the x factor. So what numbers multiply to get -5 and add to get +4? Multiply and add. Yeah, okay, cool. So it looks like some people are multiply and add people. So what 2 numbers multiply to get -5 and add to get +4? Anybody got me on the numbers? +5 and -1. Yeah, we can do it. +5, -1. Those multiply to get -5, and then 5 minus 1 will be 4. So we have our 2 numbers. These are 2 numbers. In the past, we would just put like x plus 5, x minus 1, right? So, and then we'd be done. That would be the factored version. Since this is x to the fourth, we need to have a square here and a square there, because x squared times x squared will be x to the fourth. So x squared and x squared. So then we're going to double check if any of them are the difference of squares. 5 is not a square number, so we're just going to leave it x squared plus 5. But 1 is a square number. It's 1 times 1. So we can take this right here and break it into two pieces, x plus 1, x minus 1. X plus 1, x minus 1. That is our final answer because we cannot break down the x squared plus 5 because it's addition and it's also not squares and it's not cubes. So we can't do anything with it. We just leave it there. Cool. Okay, at least. Okay. Okay. Let's do this one over here. All right. So do we have a GCF? They are in order. Do we have a GCF? Can we take something out of here? 2x. Lots of 2x's being taken out. Very common thing to be divided out. So 2x, that leaves us with x to the fourth minus 5x squared plus 4. So now we need two numbers that multiply to get 4 and add to get -5. Very similar, but not the same. Multiply to get 4, multiply to get this number, add to get -5. +5 and -1 won't work because they need to multiply to get 4. -4 and -1, yes. -4 and -1. So -4 times -1 would be +4. -4 plus -1 would be -5. So our two numbers are x squared minus 4 and x squared minus 1. All right, we still have the 2x from before. And then, yeah, Gali, can you come off mute and talk to us about how you did that next step?
All of those numbers can be what's it called? They're all like square roots. So you could split them all, and since there's a negative sign, you would have to do like one positive and one negative.
Yeah, x plus 2, x minus 2 for this one. And then x plus 1, x minus 1 for this one. And then we bring down the 2x like that. So we would split up all of these things. So we can actually turn this one into 5 different parts, 5 different things being multiplied. Okay. I do want to, I'm going to show you how to do this one because it's like a little complicated. So go ahead and write this one down here. This is probably where you would most likely use like FOIL or guess and check. I'm going to show you a trick on how to do these ones. So it is in order. There is not a GCF. So because there's no x on this one, so we can't take out any x's, and 13 is not divisible. 13 is a prime number, it's not divisible. So since there's still a number here, we know that one of these is going to be 2x squared and x squared because we need one of them to be 2. However, we don't know which one it is. So I'm going to show you a trick instead of guess and check. Miss Velasquez is going to kill me for showing you a trick, but this is just what it is. So you do 2 times 20, 2 times 20, which would be 40. And then you still have negative 13. So you need two numbers that multiply to get 40 and add to get negative 13. Yes, Ms. Velasquez will be mad at me. So we need two numbers that multiply to get 40 and add to get 13. So I'm thinking multiply to get 40, like 4 and 10, no, that would make 14. Like 2 and 20, that makes 22. 8 and 5, 8 and 5 make 13. Yeah, 8 and 5. And David is reminding me that they need to both be negative for sure. Negative 8 and negative 5, because I want to add them to make negative 13. Okay, since I multiplied the 2 times the 20, in physics, you know how every action has an equal opposite reaction, or like what you do to one side, you have to do the other, right? So since we multiplied to get 40, we now need to take that 2 back out. So we're actually going to divide both sides by 2. This is the trick that Ms. Velasquez would not want me to teach you. You're dividing by 2 because we multiplied times the 2. We did the 2 times the 20 to get the 40. We now need to divide that part out. So this negative 8 divided by 2 is going to turn into a 4 minus 4. So I have x squared minus 4. And then this one doesn't divide evenly. So I'm just going to leave it as x squared minus 5 halves. But since the 5 halves is there, I don't like that fraction. So this 2 bumps up in front right here. So this is really going to be 2x squared minus 5. It's many tricks. I don't love giving you the tricks either, but I think it's a little easier than doing the guess and check. But if you love guess and check, feel free to keep doing it. It's the same. You just have x squared instead of x. Can we factor any additional pieces here? Yes, I see some heads. So since this is a square number, we can square root it. So we would have x plus 2, x minus 2. 2 and 5 are not squares or cubes. So I just leave that one there. It doesn't matter what order they're in. If you like to do minus and then plus, that's fine. If you want to put that 2x squared one in the front, that's fine. If you want to put it in the middle, that's fine. You can do it anywhere. Okay. Okay. Finally, I'm going to do one more. I know it's annoying. So this is what we do if we have 3 terms, right? So you're using the x factor or FOIL or the multiply add, whatever you do. That's if you have 3 terms, right? And then finally, I want to show you what to do if we have 4 terms. I'm going to go 1 minute over class time. I hope you can forgive me. Okay, so factoring by grouping. This is if you have 4 terms, 1, 2, 3, 4, or 6 or 8. You can do it for anything that's even. So we are going to split up this and this into 2 pieces, right? We're going to split it straight down the center. We're going to find the GCF of the left side and find the GCF of the right side. So what I can take out of 2 and 3 is not a number, but I can take the x squareds out. So I'm going to take out x squared, and what's left over would be 2x plus 3. So that's the GCF of the left side. On the right side, I can take out a negative 4 from both sides there. I want to take out the negative so that the negative, like I want the negative to be out of the way. So I would have negative 4, and then what's left over is 2x plus 3, because negative 12 divided by negative 4 would be positive 3. So what I really, really need is for the things that are like left over to be the same, because if they're the same, that means that I can take them out of the entire thing. So I took 2x plus 3 out of the first 2. I took 2x plus 3 out of the second 2, which means I can take out 2x plus 3 out of the entire thing. And what's left over, excuse me, so sorry. what's left over is x squared minus 4. The leftovers, x squared and negative 4. Thank you for posting. All right. So the green piece went over here, put that first, and then the leftovers are over here. And then finally, I just want to check again. We're going to get so good at difference of squares. This is the difference of squares, so it'd be x plus 2, x minus 2. And I want to bring down the 2x plus 3. Okay. That is my 1 minute after class. If you want to stick around, I will do some more problems with you and I will get started. I have time right now. I know some of you probably have to go to clubs or different things, but if you want to stick around, you can. If you need to peace out, please peace out. But if you want to stick around, I will do some problems with you. Additionally, if you want to like try on your own for the next 40 minutes, my office hours start at 3:30. So if you want to pop by for office hours today, you are more than welcome to pop by for office hours. Otherwise, I will be here. Otherwise, thank you. Thanks for coming to my TED Talk. Adios. I'll see you on Thursday. See you soon. Bye, guys. Let me know if you're sticking around. You can just message me in the chat if you want to go over another problem or if you want to start the assignment. Okay, cool. Gali and Diana, do you guys want to do another factoring by grouping? Cool, Kayla, glad. Do you guys who are sticking around, you want to do another factoring by grouping? You want to do, tell me what you want to do.
I wanted to do the number 5 alone and see if I got them correct, just to see like that I actually have mastery of it.
Cool. Do this one and I'll tell you if you got the right answer or not. Awesome. Kayla, what's your question? Okay. Your audio not working. Oh, David, it's okay. David, you're welcome to head out if you want, or some of us are going to work and like answer questions and keep working. So for part 3 of the last box, Gali, did you write down this problem?
Oh yeah, I have my document open.
Oh, okay, great, cool. Okay, so Kayla, part 3, the last box, this one here. It's so laggy. Yeah, that one. Gali, if you scroll to the bottom of your document, you should see the answer key for the notes. Why did I put the signs x plus 4 instead of x minus 4? Did you hear us? Dang it, what happened? What the heck? So for this one, did you hear why this is x to the 3rd plus 64? Does that part make sense, Kayla? I saw it. I saw the O moment. Yeah, I messed up, Kayla. When I was writing it originally, I wrote negative, negative, and then I put a negative here. But then I think you corrected me, right? And put the plus sign there. Yeah. Okay, bye, Holly. So then because it's a plus sign, the first sign needs to be a plus sign. Because it's the first one always matches the problem itself. Cool. Awesome. Yeah, no problem. Can I go over factoring by grouping? Totally. Bye, Kayla. Have a good day. All right, factoring by grouping. This one. Taking so long. All right.
Yes, that one, please.
Yeah, this one. Cool. Okay. Did you have a chance to write it down yet?
Yes.
Okay, cool. So we're gonna split it in half, right? Split it in half. And then we're gonna find a GCF for the first two. So for the 2x to the third plus x squared, we want to find a GCF between those two. Do you know what the GCF would be there?
Would it be x squared?
Yeah, x squared. The only thing you can take out. So we would have x squared on this side, and then the 2 is still there, and we had 3 x's on top and 2 on bottom, so then we have 1 left on top. And then x squared divided by itself, anything divided by itself is just 1, so we'll put the 1 there. And then, does that much make sense?
Yes.
Cool. Okay, and then what can we take out of these ones?
The 9, -9.
Yeah, -9. Good to take out the negative. If possible, you always want to take out a negative. So we're going to take out a -9. What will that leave us with?
2x.
2x and?
Is it going to be 1?
Yeah, it's always going to be 1 because we don't want to just like turn it into one term. It is 2 terms, right? So we want to have it be 2 terms. So now they're the same, right? The 2x plus 1 and the 2x plus 1.
Yes.
So that means we can take 2x plus 1 out of the whole thing. So we have 2x plus 1. Like that. And then we have the leftovers here. What did we take over? We took out x squared. Yeah, so we're going to have x squared minus 9 here.
Okay.
And then
okay.
We're not done yet though, right? Because we have the difference of squares, because 9 is a square and it's a fraction. So this breaks into 2 parts like this. So we'd have x plus 3.
X minus.
And what would the second one be?
X minus 3.
Good job. And 2x plus 1, like that.
So you always break down the last one, the one you combine? Like
not necessarily. If we had only taken out like x, if we had like 2x plus 1, and then we had like x minus 9, we couldn't break that one down because there's not a squared here. So x by itself is not a square. So this would just be our answer. Like that.
Okay. Okay, thank you.
No problem. Do you feel more confident on that one? Do you want to try another one, Diana?
Yes.
Okay, there's one more here. Kat, are you still with us?
Yes, I'm still with you guys.
Okay, are you working on this next one? Or you have a question?
Yeah, just that was.
Okay.
You can't break the second part down, right? -x minus 3.
Right, you can't break it down, but you can take out the negative. So like basically you're like dividing by -1.
Okay. And then x plus 3. So it becomes x squared parentheses x plus 3 minus x plus 3.
Perfect. So you take out the x squared on both of them. And that goes out here, and the -1s come out here. Okay, so then do you have the same thing in the parentheses?
Yes.
So you can take that out now, right? So x plus 3 to start.
And then x squared minus 1.
Mm-hmm.
And then you do x minus 1 and x plus 1.
Mm-hmm. Good job.
And then x plus 3.
Yeah.
And then x plus 3. Okay.
Yeah. You got it.
Yeah, I got it now. Thank you.
Okay. You're welcome. If you want to check any of them, if you're working on the upper ones, if you scroll down to the bottom, the completed notes are down there. So you can check it out.
Okay, thank you.
You're welcome. No problem.
Hey, miss.
You too. Bye, Diana.
Hi, Ms. Mac. Okay, I finally understood the ones we were working on, but what about for the difference of squares or the sum of difference? I'm kind of lost on that one.
Okay. Do you want to do one of the ones that's like that from your assignment?
Yes, please.
Okay. Go grab your assignment.
Okay.
Do you have it open?
Yes.
Okay, cool. Let's do number 10.
Number 10. Okay.
And the way that I found it, the way that I knew it's going to be difference of squares or cubes is it only has 2 terms. So I was looking for like the only ones that might be it are like number 6 only has 2 parts, or number 10 only has 2 parts. Those are the only ones that would have either the difference of squares or the difference of cubes. And then I didn't choose number 6 because it does have x to the 3rd in it, but I can see like the x is going to come out. So then it's only going to be x squared. So it's not going to be cubes anymore. Does that make sense?
No, mine is able to you can hear. Ms. Mac, can you hear me?
Yeah.
Yes, it can. Sorry, it's because I set that my internet's on speaker. The audio.
Oh, okay. Got it.
So you said that we know that it's different of squares because it has 2 terms, right?
Yep. And then when it has 2 terms, it could be squares or it could be cubes. So if I'm looking at number 6, it looks like it's cubes, but it's not actually cubes because I'm gonna take out the GCF of the x, and that's gonna leave me with squared. Does that make sense?
Yes.
Okay, so I'm not gonna do number 6 because I was squares. You wanted to work on cubes, right? Okay, so let's do number 10. Number 10. Okay, let me find, I'm gonna write it down here so that I can, 5x cubed minus 20. Okay, so we want to make sure it's in order, which it is. Is there a GCF?
Yes, we could take out 5, right?
Yeah, we can take out 5.
And then it would be x3 minus 4.
4, yeah. x3 minus 4. Perfect. Okay, then we have to ask ourselves, is x to the 3rd is a cube? Is 4 a cube?
4 is a cube because, right? Because you can take out 2.
You can take out 2. It's a square because you can do 2 times 2. But in order to be a cube number, it needs to be like 2 times 2 times 2. It needs to be 3 of a kind.
And then you can't do it.
You can't do it. Yeah, so this is actually the answer to this question.
Oh.
Let me see if I typed something wrong here. Oh yeah, you know what? There should be an X on this problem
Number
in order
10?
to match. Yeah, number 10. It should be 20x.
Oh.
So then we should be able to take an X out like this. So we would have 5x, and then this would be x squared instead of x to the 3rd. There's a typo. I knew there would be one. I had to type all of these things by hand. That's my
Really?
fault.
That sounds complicated.
Yeah, it was really annoying. Okay, but what do you recognize now that it's x squared and 4? What can you do?
Now you can do the like x minus 4 and x plus 3. So
4 and 3? What are the two numbers that 4? What does 4 break down into?
2, x minus 2 and x plus
2. X minus 2 and x plus 2. Because you need the 2 times the 2 to make the 4. So it turns out this wasn't even a cube problem to begin with.
Yes.
Yeah. Let me message. Whoa, my computer just freaked out. Hold on. Let me. Oh man, my cable just like died, and you know how I have like 2 screens set up, and so but the cable died to the other screen, and so now I have 1 screen, but all of everything's on one side. Wow, that's really annoying. Okay, hold on. Let me go ahead and email your classmates that there's a typo. So it actually looks like there's no difference of cubes on here. But do you want me to make up a difference of cubes problem so we can do it?
Sure. Yes,
Okay.
please.
Can you still see my screen?
Yes, I can see your screen.
Okay. Why don't we do x cubed minus 3, x cubed minus 81. We'll do that one.
Okay. You could take out 3 from both of them.
Take out 3 from both of them.
And then x 3, and then it would be minus 27.
Okay, it's 20. Oh, go ahead. Go. You got it.
27. 27. You could. It could be 9, 9, and 9, right? Because
9, 9, and 9 would be 9 times 9 is 81 times would be a big 729, I think. The smaller number.
3.
3. 3. Okay. Go ahead.
I don't know. So then it would be. Oh, well, how would you do it though? Because if it would be like, you know how in the other one it would be x minus 2 and like x plus 2. But then since there's 3 now, how would we do it?
So the 3 is here, and then you would have x to the 3rd, and you would have 3 to the 3rd, right? Like that?
Yeah.
So the formula is AB, A squared, AB, B squared, like that. So A is x. So every time we see A, we're going to put in an x. So it'd be like x, x squared, and x, like that. And then B is 3. So we're going to put in 3 and 3 and 3. It'd be like 3, 3, and 3 squared.
So the first one would be x minus 3 because you'd stay with the same and there's a minus.
Yes,
then,
perfect.
X squared. And then it's, what's the little thing opposite, which would be plus, and then 3x, or do we leave it the same? Oh,
no, 3x, you're right.
and then it would be always this, always positive. So plus 3.
It's 3 squared.
Oh, 3 squared. Oh yeah, because b and that would be the final answer.
What would the last number be? What's 3 squared?
Oh, 3 squared, 9.
9. Good job. Like that.
Oh.
That's it. Oh, don't forget your 3 from the beginning though.
Oh yeah. Oh, and then that's once you get that, that's like your final answer, right?
Perfect.
Oh, I get this now. Thank you, Miss Matt.
You're welcome. No problem. Happy to help.
Thank you. Bye.
All right. I'll see you later. Bye.